Ladies and gentlemen, today is day number 2 of descriptive statistics. All right, let's go ahead and take a look at our goal for today. So today we should be working in our packets again, but today we are on day number 2. Our goal for today is to practice with the mean and the median. Also, part 2 for today's goal is to graph and interpret a cumulative histogram. All right, so let's jump right into our lesson for today. So here we go, day 2, practice with our centers. All right, so we have to remember a center. We measure our center in 2 different ways, using the mean and the median. Remember, the mean is the arithmetic average. All right, and the median is going to be the middle number when your data is in ascending order. All right, so let's go ahead. Let's take a look at our very first data set. So number 1, given the set of data, 3, 5, 7, 20, and 35, calculate the mean and the median. So let's go ahead and try the mean first. So the mean, we're going to average everything together. So we add up all of our numbers. We divide by how many there are, which is 5. Okay, we're going to get 70 over 5, which then gives us a grand total of 14 as our average. Remember, the symbol for average is X bar. So the mean is 14. Now let's take a look for the median. Now our numbers are already in chronological order, so all I have to do is find the middle. There's 5 numbers, so my middle is the third number, which is 7. Okay, what we're going to do now is we're going to take a look at a couple different examples where we are going to manipulate the data that's given to us. So for part B, it says add 5 to every number in the data set from above. So let's take a look. Our first number is 3. If we add 5, we'll be at 8. We're adding 5. So 5 plus 5 is 10. 7 plus 5 is 12, 25, and 40. Go ahead now, hit pause, and I'd like you to calculate the mean and the median for our new data set. All right, let's see if our answers match. So I was able to get the mean as 19 and the median as 12. So let's take a look to see what happened when we increased every single data point by 5. Well, our mean started at 14, and now it's 19. Our median started at 7, and now it is 12. So what happened is if every data point, so if every piece of data is increased, then both the mean and the median will also increase. So when you affect every single piece of data, the center is also going to change, no matter which center you're using. So let's see what happens now where instead of manipulating and changing all of the data, we're going to use the original data set and we're going to triple the largest number and decrease the smallest number by 3. So all we're going to do right now is we're going to change the biggest and the smallest number. So let's go ahead and take a look. So we're going to triple the largest number. So the largest number was 35. We're going to triple it, and we're going to have 105. We're going to take the smallest number, and we're going to decrease it by 3. So if I start with 3, and I decrease by 3, we're going to have 0. Go ahead now, pause the video, and I'd like you to calculate the mean and the median of our new data set. All right, let's take a look and see if we concur with our solutions. All right, I came up with the mean as 27.4 and the median as 7. So let's take a look and see, well, what changed with our centers when we manipulated only the endpoints of our data? So our original mean was 14, and our new mean is now changed to 27.4. Our median started as 7, and now it remained at 7. So if we take a look, what was affected by changing just the endpoints of the data? That's right, only the mean value changed. The median remained the same. So let's go ahead and let's write that down. So if only the end data points change, only the mean will change. The middle of the data remains the same, hence the median remains the same. So that's just kind of a neat example of showing how manipulating the data can change the center of your data. All right, let's take a look now at two other problems that work with mean and median. So question number 2. Emily recorded all her test grades as 76, 88, 94, 96, and X. So we don't know what that last test is going to be. So question A, if the median of Emily's math grades is 88%, which test score below could be Emily's X grade? Well, let's go back and reread the question to find our statistical words that we want to use. So our statistical word here is the median. She wants her median, or the middle grade, to be 88. So let's go ahead and let's see how we can do that. So we're going to take her original test scores and let's put them in chronological order. So 76 is the smallest, then 88, 94, and 96. Okay, we want her median, the middle grade, to be 88. So I'm going to circle that. I want this to be 88. So where should I put the X test so that way 88 is in the middle? Well, I have 2 on the right. There's only 1 on the left, so I'm going to put my X test on the left. So let's look at our choices. Which of these choices has a test value less than 88? And that would be test number 4. So 83% would allow her median to remain at 88. Okay, now let's take a look at question B. Now, if the mean average math test score for Emily is 88, what test score below could be Emily's X grade? So now the statistical word we're using is the mean. So we want the mean, or the average, to be 88. So let's remember, to find the mean, we have to add up all the tests and divide by how many there are. So let's go ahead and do that. So 76 plus 88 plus 94 plus 96 plus X all over 1, 2, 3, 4, 5. So we're trying to find out the value of X. Now we want the mean to be equal to 88. All right, I'm going to go ahead now and I'm going to simplify this. So I'm going to add these 4 tests together. And when I do that, we get 354 plus X all over 5 equals 88. Now I have a fraction equal to a whole number, so I'm going to put this whole number over 1. And now we can cross multiply to solve for X. So a binomial times 1, well, that's going to remain the same. So here I'm going to come over to here now. So 354 plus X is equal to 5 times 88 is 440. So to solve for my test grade X, I'm going to transpose the 354 to the other side. And when I do that, I get X to be equal to 86. So her 5th test grade would have to be an 86 in order for the average to be equal to 88. All right, so ladies and gentlemen, that's our practice with our centers. All right, so that was the first part of today's goal. Now let's go ahead and take a look at the second part of today's goal. All right, so here we go. Next up, are cumulative frequency histograms. Now the word cumulative means you're going to be combining everything together. So we're going to make a cumulative histogram, which is just a bar chart. But what we're going to do is we're going to take our intervals, and instead of having even intervals, we're going to accumulate them together. So they're going to grow bigger and bigger and bigger as we go along. So we're going to start this just like we would a regular frequency table. We're going to take our data set. So here it says the following data represents students' weights in pounds that are enrolled in algebra. We're going to take these weights and we're going to put them into a general frequency table. So I can see there's 2 students between 80 and 99. There are 6 students between 100 and 119, so on and so forth. So now what we want to do is we want to convert this into a cumulative frequency. So that means my first interval is going to stay the same, 80 to 99. There are 2 students in that range. Now my second interval, what we're going to do is we're going to start at the beginning. So I'm going to start at 80, and this time I'm going to go all the way up to 119. So how many students are 80 all the way to 119? So from the beginning up to and including the current interval, well, that's going to be the 2 and the 6. So altogether, there's 8 students that are in that range. To get my third, I'm going to again start all the way back at 80, and this time I'm going to go all the way up to 139. So how many students are 80 all the way to 139? Well, we start at the beginning and we add all of those together. So that's 2 plus 6 plus 2. So altogether, that's going to be 10. My fourth interval then, again, starts at 80, and this time goes all the way to 159. So let's go up to our frequencies. So that's from 80, which is the beginning, all the way down to 159. So now I'm going to be adding all of these together. 2, 6, 2, and 5. That's going to give me a grand total of 15. And now for the last one, again, we start at 80. We're adding everything together all the way up to 179. And now I'm going to combine all of those. And I'm really just adding one on, and I get 16. So now what I'd like you to do is I'd like you to hit pause, and I'm going to ask you to go ahead and create a histogram using this data right here. All right, go ahead and hit pause. All right, welcome back. So let's take a look at that cumulative frequency histogram. So let's double check. Do you have frequency going up the Y's, and that's the number of students? You have your weight and intervals going along the x-axis. I'll zoom in here. All right, we have a title. Now we had to have a little break there, and then you can see your interval 80 to 99, 80 to 119. If you look, each one keeps growing and growing and growing and growing until at the very end, you have all of your students combined into one interval. All right, so now that we have graphed our cumulative frequency histogram, let's take a look now at interpreting it. So question A, how many total students were in the class? Well, by the very last interval, we should have all the students in this last one because we combined them all. So there are a total of 16 students. All right, how many people weigh, let's get rid of the word at, okay, weigh less than 100 pounds. So let's take a look. This first interval is everybody that weighs less than 100 pounds, and if I look, there are 2 people in that interval. Next, how many people weigh more than 140 pounds? Well, if I take a look, 140, there are, if I take a look here, this is up to 140, there are 10 people that weigh less than 140 pounds because that's everybody that's between 80 and 139. I know that there are 16 total people in the study, so that means 16 minus 10. So there are 6 people that weigh more than 140 pounds. Okay, so now question D. What is the difference between a histogram and a cumulative frequency histogram? Right, well, here we go. A histogram organizes data into equal intervals. A cumulative histogram organizes data into intervals that combine together all previous intervals. All right, ladies and gentlemen, this is the end of the lesson. Thank you for watching.